Hello everybody, my name is Geraint and I'm a researcher at the Open University. What I'd like to do today is take you on a journey that's over 30 years in the making and travels nearly 4 billion miles around our solar system. I'm an analytical chemist, and along with my colleagues I've been developing systems and applying commercial systems to answer some of the big questions we have out there. Whether that be sniffing comets, meteorites, or developing systems to measure the air quality in submarines, and even looking for fake whiskey. So let me start with comets. Comets are amazing things that are left over from the beginning of our solar system. They're probably 4.5 billion years old and spend most of their time well outside Mars in a place called the Kuiper Belt or the Oort cloud. Every now and again they collide and come in towards the Earth, and we get this wonderful image that you can see here from the Southern Observatory in 2010. So comets, as they get closer to the Earth, they're basically dirty snowballs, will start to evaporate and produce vapor and gas trails, which is what we see as the tail of the comet. But in reality, the comet itself is actually quite small. The nucleus, the hard part of the comet, is only about 4 kilometers across. And this is the comet that we went to with the Rosetta space mission. And it's a comet called Churyumov-Gerasimenko, and it's named after the Ukrainian astronomers who discovered it back in 1969. And as you can see from this image, this comet would actually fit quite easily between Big Ben and the Tower of London, as it's only about 4 kilometers across. So it's quite amazing how the European Space Agency were able to design a rocket and then an orbiter system which actually allowed us to chase and catch up with this comet before landing on it in November of 2014. This is an image taken a month before we landed. So this is a picture taken by the Shiva camera on the lander, looking out over the orbiter and the solar cells of the orbiter to the comet in the distance. So this was about 16 kilometers away in October of 2014, and this is probably the world's most expensive selfie. It also contains one of the oldest and one of the youngest things in our solar system. The instruments we built in collaboration with Rutherford Apple Laboratories in Oxford was a miniaturization of lab systems that are probably the same size as a family car. We actually shrunk it down to something the size of a shoebox that weighed just over 4.5 kilograms and used less power than an old light bulb. We built this in the 1990s. It was put on board the lander, as you can see in the bottom right hand picture, in around about 2001, September of 2001, and we launched in 2004. And as I mentioned, we spent 10 years chasing the comet around the solar system before landing on it at a distance of about 3.5 times the distance the Earth is away from the Sun, so 3.5 AU. So before the comet became really active. We had quite an exciting landing, or rather we bounced a few times before eventually landing, and we were able to take data from that bounce period, and indeed some of the dust actually went inside our instrument and we were able to analyze its chemical composition, and we were able to conclude that the building blocks of life, so complex organic compounds, are indeed present on a comet. And so comets, back in the early history of the Earth, could have brought the building blocks of life that we're all made from, and water, to the surface of the Earth. Now, space is quite an amazing place, and quite often the Earth is bombarded by meteorites. So meteorites are rocks that are present in space, usually asteroids, left over again from the formation of the planets. So if you see a shooting star, you're probably not seeing a comet, you're probably seeing a meteorite. We had such an event back in February of 2021 when a meteorite was seen to fall on the driveway of the Wilcox family in a place called Winchcombe, which is just outside Cheltenham. It was actually a very exciting meteorite, one of only 51 known. It's a carbonaceous chondrite, which basically means it has a lot of organic compounds. So I was involved in analysing the volatile organic compounds, But there are 120 plus other scientists around the world who also analysed this meteorite. And they were able to explore and identify things like amino acids being present, and also quite a lot of water. So the jury's now out on meteorites could also have brought seeded life on Earth rather than a comet. So the debate continues and the science goes on. So one of the things I'm quite often asked is, what has space ever done for me? And in reality, it's not Teflon or comfy beds. Probably the biggest impact space has had on us all is the invention of Wi-Fi. And Wi-Fi was invented by radio astronomers in Australia, and that was because they were having issues with trying to get good signals. So they developed a methodology where they could break it up into packets and send multiple beams of signals and actually improve the response they got. And these are techniques that are now used in all of our mobile phones and in our home Wi-Fi systems and connecting our tellies and computers to allow us to do everything we do every day. So if anyone asks you ever what space has done for you, then remind them of the value of Wi-Fi. And what I'm going to do with the rest of the talk is hopefully give you some more examples of how the group at the OU have worked with collaborators back here in the UK and across the world to develop new solutions to problems here on Earth. Probably our most impactful project was developing an air monitoring system to measure the air quality on board of a submarine. Submarines are big metal tubes with over 100 people on board, and they are part of our strategic defence capability. We developed this air monitoring system, so taking this complex problem, developing a scientific and engineering solution, and then proving it on board a submarine. And this has allowed a UK company, Analox, to now take this forward. We've broken a 30-year US monopoly on the supply of these systems to the NATO fleet, and more importantly, we're providing a much safer working environment for all our sailors. In addition, we've also developed systems for more day-to-day products. So Geraint are one of the world's largest fragrance companies, and they develop the fragrances for things that we all use every day, like shampoos and washing powders. And we've helped them up to date and optimize their particular formulations using some various techniques that we've developed. But again, it's about us being able to build a robotic system that answers the scientific questions of interest to them. We also invest in developing, or rather working in partnership with instrument manufacturers, and in particular this is the Leico system, a US manufacturer, and we work with Leico Europe to develop novel assays that allow us to look at complicated samples in unprecedented detail. So we can see the wood that's hidden beneath the trees, and in fact we can see the flowers hidden beneath the wood beneath the trees. So we apply to a whole range of different applications. Most notably for this festival is Scotch whisky. So here you can see our analysis of a Scotch whisky sample. We can identify and quantify well over 400 peaks in, for instance, a Glenfiddich Scotch whisky. We can then use those techniques to explore and apply it to the development of new products, but also to help identify fake and adulterated whisky. So this just shows you in more detail some of those areas in the chromatogram, but here you can see peaks that would normally be hidden, and some of these compounds are very important for the flavour of the whisky, and indeed if it was a fake whisky could be very important in actually being able to identify it and take it off the market. Not only do we do whisky, but we also work with other people to develop new products. So for instance, in this case, we worked with a company on looking at their rum flavourings and helping them understand how they might have to change their recipe, which compounds are present in real rum that are not in their samples, and conversely, which compounds are present in their samples but not in real rum. So the techniques we have not only can be applied to developing new solutions, but also helping protect certain brands. So the actual, we also do a whole range of different applications, and unfortunately there's no time to go through them, but here's just an example of collecting some of the different things we've applied our sifting techniques to allow us to be able to answer certain questions. So that's it from me. If you have any interesting problems you'd like us to explore, then please feel free to get in touch with me, and my email address is at the beginning of the talk. Thank you.